Good afternoon, everyone. Thank you for joining us here today. I'm going to get things started. We may have some folks rolling in to join us, but we'll get going with introducing this virtual learning session. Um, I'd like to introduce myself first. I'm Dr. Carolyn Chang, and I serve as the director of our Department of Education Title III and V programs in academic services at Texas State, and I'm currently a faculty fellow with the Translational Health Research Center, working in the STEM and healthcare workforce area of focus with Dr. Stephen Whitten, who joins us today as well. I will be facilitating this Inspire Echo series and continuing to work with Steve as well throughout these three sessions on this initiative. Steve is serving as a panelist today, so you'll hear from him in that capacity. I am delighted to welcome you to our kickoff session, this first session for the Inspire Echo. We're going to explore industry-synced pathways for innovation, research, and employment. This series was designed to spotlight how student training programs in higher education are engaging with industry partners and preparing students for the real-world challenges and opportunities of the STEM and healthcare workforce sectors. Over the coming weeks, we'll hear about how these partnerships support innovation, foster robust pipelines, and contribute to student and regional success. Our first session today is titled Laying the Foundation. We're going to explore Texas State's current and past training programs, and we are excited to feature 4 programs in particular at Texas State that have exemplified and do exemplify currently workforce-aligned training in research and innovation. Our panel today includes Dr. Tania Betancourt, Professor of Chemistry and Biochemistry and Principal Investigator of the NSF-funded Texas State UT PREM Center for Intelligent Materials Assembly, which is a partnership with UT Austin focused on preparing students for advanced study and careers in the material sciences. Dr. Rebecca Davio, Associate Professor of Practice in the Department of Geography and Environmental Studies and Director of the Institute for Government Innovation at Texas State, which provides real-world experiences to students working with government and nonprofit organizations across Texas. Dr. Damian Valles, Assistant Professor in the Ingram School of Engineering and Principal Investigator of the NSF REU site, undergraduate research experience in artificial intelligence, data analytics, and mixed reality for smart and connected health, where undergraduate students gain hands-on experience in emerging technologies with health applications in collaboration with Texas A&M San Antonio. And Dr. Stephen Whitten, Associate Professor of Chemistry and Biochemistry and Principal Investigator of the NIH-funded Texas Doctoral Bridge Program, which supports master's students in biomedical sciences to successfully transition into PhD training. Each of our panelists today has expertise in running programs that combine experiential learning, research training, mentorship, and industry or community engagement, and each will provide a unique and complementary model for how we can contribute to preparing our students to succeed as the next generation of researchers, professionals, and innovators. This series, is my second time leading an ECHO series with the Translational Health Research Center. Some of you may remember the Texas Clinical Research Workforce series that we hosted last summer, which was a series focused specifically in clinical research, and it sparked powerful discussions on workforce development in Texas. So this year we are expanding the conversation across the broader STEM and healthcare workforce sectors and highlighting programs and partnerships that move students from the classroom to the lab to the workplace and contribute so that they're ready to contribute and lead. I want to preemptively thank our panelists for speaking today and being with us, and we look forward to your insights, your questions as we move through today's session. And if you are joining us today as a participant. We will have time for open question and discussion, so please feel free to add your questions to the chat or wait until the panel questions are done, and you can use the raise hand feature. So we'll get going. We're going to ask 4 rounds of questions across all panelists, and our panelists will respond in the same order each round, so we all kind of know what to expect. So we're going to start with our first round, where I would like to ask all our panelists to briefly describe their program that we're featuring today and its main programmatic goals. And we'll start with Dr. Betancourt.
Well, hello, everybody. As Caroline said, my name is Tania Betancourt. I'm a professor in the Department of Chemistry and Biochemistry at Texas State. Thankfully, I still have the privilege of being the director of the Texas State PREM Center for Intelligent Materials Assembly. We are funded by the National Science Foundation. And as Caroline mentioned, this kind of grant is meant to enhance opportunities for students to participate in materials science through both research and educational opportunities that are helped through a partnership with NSF-funded center. And in our case, that is with the University of Texas at Austin. I want to go ahead and thank Caroline, Steve, and Shelby for this opportunity. So if you can show the slides really quickly. Thank you so much, Shelby. Let's go ahead and go to the next slide. So our PREM Center, as I mentioned, our PREM Center is called the Center for Intelligent Materials Assembly, or CIMA. And we specifically chose that name because CIMA in Spanish means the summit or peak of a mountain. And so we were hoping to utilize this as our vision for the center, to be able to provide the students all of the tools that they need for them to get to the top of their preparation. We do this by providing the students mentorship, research, a community where they belong, and the partnership with, in our case, with the Center for Dynamics and Control of Materials at UT Austin. As you can see, we are 30 miles away, which could be 30 minutes or 2 hours, depending on the time of day. But we've been very fortunate to have UT Austin as our partners. One of the reasons is that we have really good overlap for the research interests between the faculty that are involved and the faculty at UT Austin. Also, they are very much committed to this partnership, and so they put a lot of time and effort into all of the activities that we do together. And lastly, unlike most of the other PREMs in the nation, we are close enough within driving distance. So that gives a lot of opportunities for student and faculty exchange, for materials transfer, for students to go and train and utilize equipment at either of the centers. And so that has really helped with our center in with providing opportunities to our students year round. Of course, our center, because it is funded, it focuses both on the research and education. So it plays an important role in the Run to R1 that our university is in at the moment. And so the university has also provided significant support to our program. If you go to the next slide, I wanted to show that we have 12 faculty members that are currently engaged in this center. The faculty are from the departments of chemistry, biochemistry, and physics, and more or less they're organized into 2 different research trusts on reconfigurable soft materials, and then control of nanostructure and energy for electronics. All of the faculty members are also involved in our doctoral program in material science, engineering, and commercialization. And I think I'll leave the introduction. Thank you.
Thank you, Dr. Betancourt. We'll move to Dr. Davio.
Good afternoon, everyone. Carol and I, too, would like to say thank you to you and to THRC. Shelby's done a lot of work to put this together, too, keeping us all in line. So I'd like to thank you for that. I'd also like to thank the folks that are attending. It's always great to be able to share and collaborate with different ideas. And I am the director. My name is Rebecca Davio, and I am the director of the Institute for Government Innovation. And because we have government in our name and work with government agencies a lot, we sometimes refer to us by the acronym IGI. So if I slip and say something about IGI, you'll know it's the same thing. And the Institute for Government Innovation is an on-campus consulting center that is really powered by students. And so it's a fun concept. It's been around since 2003. I don't get to take credit for starting it, but I took over as the director in 2015. And we do projects. We help find solutions for challenges for city, county, state government agencies, and nonprofits. And I think because I'm an associate professor of practice, I don't have to focus exclusively on one particular area. I have broad background in education and broad background in my work. And so we take on a very diverse range of projects for our clients. We have done, over the time that I've been here, we've done, I think, 64 projects, ranging from legislative research reports to an animated kids video to help increase safety in schools. And we do lots of GIS work, geographic information system related work, or incorporate that into our project because we're in the geography department and it just naturally makes sense. It's sort of the way it influences how we think. And so it's our primary goals are twofold. They're to help our clients address their issues and to help students get real world learning experience to complement their academic learning. And I think our mission really says it nicely and succinctly. Our mission, the Institute for Government Innovation, is improving today's decisions and tomorrow's decision makers. So we do a lot of data-driven decisions. We follow research practices, sound research practices, very applied work, and then also deliver very consumable, even our legislative reports, we like to think stand out a little bit from some of the typical plain government agency documents, because the purpose of a legislative report is to compel people to read it and be persuaded, the legislators, to take action. So that gives you an idea.
Thank you, Dr. Davio. We'll move to Dr. Valles.
Good afternoon, everyone. My name is Damian Valles. I want to thank everyone again for putting this together and for the invitation to speak. I'm wearing many hats, but in this one, I am the PI of an RU that we have every summer for the last 4 years that deal with AI and health-related research. In the iteration that we're currently in, we look at the collaboration with Texas A&M San Antonio, mainly because they have an Institute of Research for Autistic Children. And part of that effort is that our technology development that we do at Texas State and the collaboration with A&M San Antonio helps us to push the research even further to improve the development of this autistic children in our area. So what we focus is, like I said, it's AI driven. We look at different projects across the health spectrum, besides the autism spectrum disorder. We do also work with faculty from our Department of Health and Human Performance that deal with spinal cord injuries and ankle injuries as well. And we apply AI and data analytics to help these type of research to be enhancing either technology-wise, modeling-wise, simulation-wise. And basically our goal here is that we have an interdisciplinary experience for the students who come from different universities and some from our own institution to gain that experience in a research lab, what it takes to develop something from scratch, to understand what the research development is. For the first time, many of them are working with human subjects. That's an interesting process to teach. And the goal here is that It's not just the experience, but NSF wants us to really encourage graduate school. And we want them to definitely consider our programs, but most of them do go to graduate school. And lastly, we want them to publish, right? The goal here is that their efforts in the 9 weeks that they spend with us here at Texas State, that they become scientists for the first time. And we do go through an engineering process of end-to-end design, which I think they like a lot because it's a lot of hands-on. But the challenge is that it's a limited time. 9 weeks seems like enough, and then it's not, right? And so we get a lot of applications nationally, mainly because they see our research as very meaningful with an actual drive purpose of actually helping people from the technology we develop. And so I'm very proud of what we've been able to accomplish the last 3 summers, and we're getting ready to crank it up again for the next 3. And we're hoping to have very successful. We just finished recruiting our positions, and we're going to have great talent coming over this summer. So our link is on the chat. You're welcome to browse through it, and happy to answer any questions. Thank you.
Thank you. And Dr. Whitten.
Thank you, Carolyn. Hi, I'm Steve Whitten. I'm PI on what's called a Bridges to the Doctorate training program that's supported through the National Institutes of Health. This Bridges to the Doctorate program is designed to help MS students transition to a biomedical PhD program, and it's a collaboration. The way these are designed are to be a collaboration between a MS granting institution, so in this case, Texas State, and a PhD granting institution, in this case, UT Health San Antonio. So these can't be used to transition your own MS students to your own PhD programs or across 2 campuses. It is quite an involved training program, so I do want to recognize the co-PIs on this program. Here at Texas State, it's Karen Lewis, and at UT Health San Antonio, it's Doctors Keo Joby and David Libich. This collaboration between the 2 schools for this Bridges program has actually been ongoing since 2013, so we've been renewed multiple times. Once in 2018 and again in 2024. And the reason we've been able to be renewed is because we have been successful in transitioning our MS students to PhD programs. Of the students that have gone through this Bridges training program, over 70% have been able to transition to a doctoral degree program. And more importantly, of those that transition to a doctoral degree program, over 90% have either earned the doctoral degree or they're still in good standing in those degree programs. So they're still working through. And so those are really good numbers. And so with this program, there's been a lot of very, very talented students that have been associated with it, and a lot of talented faculty too. I can't recite all their names by memory. There's so many, but there's a lot of faculty from the Department of Chemistry and Biochemistry that are mentors in this program. So Tania, who's here, is one of the mentors. Same with Sean Kerwin. I think I saw him on the participant list. Same with Karen Lewis, but also faculty from biology, computer science, math. Lots of faculty at UT Health San Antonio too, over 20 faculty there. And so a lot of people have put a lot of effort into this program and have helped a lot of students.
Thank you. We're going to transition to our next round, and I'll move back to starting with Dr. Betancourt. And so now I'm going to ask you to share, who are your students, your program participants, what type of student, what major, level, or background, and then how do you recruit and support them?
Shelby, if you could please share the slides. So in the PREM Center, we utilize this pathway model that is shown on the slides, where we involve students in 3 levels. The first level is a PREM associate. So what we call a PREM associate is going to be a student who is interested in learning about opportunities for participating in undergraduate research or experiential opportunities. And so these are students that we bring into our events so they can meet the faculty and the students that are involved already. They can learn about the types of opportunities that we have available and eventually graduate into becoming PREM researchers. So a PREM researcher is going to be a student that is actually working in one of the PREM labs with one of the faculty mentors that I showed previously. The students that are doing research, they receive one-on-one mentorship from the faculty. They participate in research, hands-on research, where they learn new techniques and they apply what they're learning in the classroom. They gain technical skills in addition to, oral speaking or oral technical speaking, etc. They also have opportunities for participating in REU programs at our partner at UT Austin, etc. And then eventually the students graduate to, becoming actually graduates and either go to graduate school or join the workforce in material science. For recruitment purposes, we utilize a number of avenues. I'm showing here a picture of one of our open houses in which we bring students and we actually fill out rooms with 100+ students who are interested in learning about these opportunities, and they come and meet with faculty members. We've done this in a number of different ways. One of the ones that seems to work the best is kind of speed dating, where the faculty mentors kind of rotate in between tables and introduce themselves and introduce the work that they're doing. But we've also done kind of open houses where the students are able to walk to the various labs and see what's going on there and meet with the students. We've also done faculty presentations, etc. Once the students are in the program, we do almost weekly meetings where we have student professional development and such. We also have research meetings and other activities that I'll mention later. And then we also try to celebrate our student successes through a number of different kind of social events that help to kind of build that community and to highlight our students to, keep doing really great work. If you go to the next slide, I just wanted to show you kind of the cohort. That first picture is from our 2021-2022 cohort, which is when we started our first PREM. And if you click again, you'll see our current cohort. So this year we have 42 students that are supported through the grant. That includes 9 graduate students and 33 undergraduate students. And then in addition to that, we have 38 students that are affiliated. And affiliated means that they are doing research in one of the PREM labs, but they're not being financially paid stipends from our program. They do participate in some of the professional development activities. Most of the students in our program come from either chemistry, biochemistry, or physics, and we also have some students that are in biology. But basically, we have any student who is interested in participating in material science research. And material science is a very broad field. We do everything from biomaterials that have applications in drug delivery, diagnostics, all the way to semiconductors, materials for energy, and such. We've also had more or less 60 graduates that have graduated from our program in this cohort. 22 of them have gone to get their master's or PhD degrees. And then we've had also, I think it's 17 students that have gone to the UT partners to participate in their REU program. I think that's all that. Actually, no, there was something else that I wanted to mention. So if you go to slide 12, if you're able to. So yeah, we've had 17 students that have gone to the REU program at UT. We've had students, click. So 2 students that have finished their honors thesis. We have had 11 first-time publications, basically 11 students that have been authors of publications for the first time. We have numerous outstanding presentation awards. We've even had a student who won an entrepreneurship award, multiple scholarships, and if you click once more, numerous students who have gotten outstanding senior, graduate, or doctoral student awards. So we're very, very happy about what our students have been able to do. That's all I wanted to share. Thank you.
Thank you. Dr. Davio?
I'm so glad to hear all your federal funding has kept going. That's wonderful. We don't do any projects with federal funding. We actually are funded through our projects. So all the students are paid, and we work, like I said, for government and nonprofit agencies. And we try and hire juniors, seniors. They have a little bit more experience. I will tell you that we hired our first sophomore. It's just an exceptional student that was very involved, very mature, had great skills. But we also hire masters and PhD students. So that's it's really nice for our international students. Sometimes we're able to find them. They can work here on campus during the summer when their TA and GA assignments lapse. So that's something, but we really we do less formal training because we have to balance delivering a product to our clients with student learning. So our students tend to do very applied learning, and they get one-on-one mentorship for their particular task. So if they're learning to use Excel, for example, or they need to use that in the project that we're doing, we provide that training and coaching with them. And so it's not formulaic, it's very customized. And, many of our students have told us that they're using the skills that they learned here. That's either the reason that they got the job, or they're using what they learned in their job. So that's always really wonderful. We do try and create sort of a team atmosphere. So we, for example, really want to hire a minimum of 2 students for a project. Not so many students that it's hard to manage and that they get very diluted experience, but at least 2 students so that they get that collaborative team experience and understand what it's like to have to support somebody else sometimes, but to also have those resources to call upon. And we're a small team, so myself and the direct staff supervisor work on every single project very closely, very directly. And because we work on such a diversity of projects, we're able to recruit students from across the campus to do that work. So it depends upon what their interests are, what our particular projects are. And many times students get the experience, which I find to be a very real world experience of they have some background knowledge, but they really don't have expertise in the topic that we're working on. So for example, a geography and environmental studies student, we had several of them working with us when we did 20-year strategic solid waste management plans. We did 8 of those for different COGs around the state. And the students didn't have expertise in that area, but they very quickly, they went from being novice to at the end of the project, they make presentations to the clients. And so they get that experience. I think I'm crossing over a little bit into information for the next time, but I'll just give you a teaser.
Thank you. Dr. Valles?
Yes, so in our case, NSF are basically open call nationally to all undergraduate students. In our case, we take U.S. citizens, permanent residents. As far as classification goes, sophomores, juniors, seniors that are not graduating would be the ideal case. However, we made an exception this year, and we're actually bringing in a couple of freshmen. I'm rolling the dice on that, and I know I got a little bit of pushback on that. But so what we try to encourage in our applications is do they have a good sense of the type of projects we're working on? And that's the difference sometimes in the personal statements from seniors to freshmen. But it seems like there's a lot of a purpose from these students to wanting to do research, and they're already thinking of graduate school, which is impressive. at no point as an undergrad, I was thinking about graduate school. And the fact that they're better off already than I was at their age gives me really good opportunity to work with talented people, talented students from all over the country. And uh, we've been able to successfully help them become first-time publishers, the way Dr. Betancourt was speaking about, which reminded me a lot of that. And most of them, well, some of them get a little bit too addicted to it, and they wanted the process to continue, right? And we want to encourage that in their own institutions. At the same time, bringing in the new cohort, it's a fun thing to see the type of vibe they bring to the table, because every year the cohort tends to be different and they behave differently, but they do kind of come together and they work together, but they have different personalities, and it's fun to see that work. But in our way of recruiting and doing all that, I span all my friends across the country. A lot of departments, chairs everywhere. There's some open marketing that some schools do, but mainly social media, because that's where the kids live. I do focus a lot of that attention to social media as well. So, but so far so good. It's paid dividend to our REU for the last 3 years. So, thank you.
Thank you. Dr. Whitten?
Hi. Okay. So for our students, since it is a MS to PhD bridge program, what we recruit from is from basically all the students that, as they are accepted into MS degree programs here on campus, primarily biology, biochemistry, chemistry, computer science, and math. Although historically it's been mostly biochemistry and biology with some chemistry. So we recruit from that pool of students. We also contact faculty in that department, ask them if they have any incoming students that we're not aware of, and then we strongly encourage them to apply. Also, faculty give talks at nearby institutions. So sometimes students come from non-Texas State undergraduate programs. Also, the NIH, they have a website where they list all the bridge programs with a link to them. And so if students are aware of these sort of things, they contact us through links on that site. Historically, about a third of our students that have gone through the bridge program have did their undergraduate work at a non-Texas State institution. And for the students that we can support, really the key is that their MS degree is in a biomedically relevant area, that the MS degree has a thesis requirement, so they do have to do a thesis project, and then their thesis project has to be biomedically relevant, because the idea is to train them on the pathway to go towards a biomedical PhD program, to go in that direction. The support that the students receive, in addition to a lot of professional development, and I think one of the sets of questions ask us about those sort of things. So I'll wait till then to discuss that. But they are supported at least now, because it changes throughout the year, at the equivalent of a little over $28,000 a year stipend, with 60% of tuition and fees reimbursed. And the idea is with that stipend, with that reimbursement, they can focus more of their training, in the research direction, in a research lab, getting that training that they need to successfully make that transition.
Thank you. And we'll move into our third round question. And so the question, and we'll start with Dr. Betancourt, is what specific skills, knowledge, or experiences do students gain through your program that prepare them for their future career goals?
Thank you. So one thing that I forgot to mention last time is that we also fund the students that are in our program. So graduate students receive either doctoral or graduate research stipends, and then undergraduates are paid on an hourly basis. But now coming to this question, so as I mentioned, most of the students or all of the students that are researchers, they participate in formal research in a lab. So they receive direct mentorship from their faculty advisor. They receive training on particular research techniques, and they have that paid hourly position or paid DRA or GRA. The students are also engaged in research seminars. So that could be faculty speakers that we bring to campus. We've also started doing, inviting graduate students and postdoc from our partners at UT Austin to come and interact with the students and give seminars. And we also, support travel for our students to go to professional conferences where they can present their research and also be exposed to research that is being done elsewhere. We also have professional development. As I mentioned, we have kind of weekly meetings on Fridays where the students can, participate in career panels when we bring faculty or industry folks or government laboratory folks to talk about their experiences in material science. We also have workshops on a number of different things, like how to apply to summer REU programs at other sites, how to apply to graduate school, how to apply to scholarships, both internally and externally. We've had workshops on entrepreneurship and technology transfer. We've talked about how to navigate relationships in a lab with their colleagues, with their peers, as well as with their faculty supervisors. We've talked about financial literacy, as well as how to develop and kind of perfect their resume and personal statements for whatever comes next, whether that is grad school or the workforce. We also have the ability to participate in this industrial mentorship program that UT Austin organizes. So our students can be participants in that, where they are paired with an industry person that they can meet with on a monthly basis to talk about, what is it like to work in industry, what kind of skills should they develop during their stay at Texas State and such. We also have leadership opportunities. So for example, right now we are organizing a conference where we're going to bring students from all of the PREMs in the nation, and it is the students that are organizing this conference, so they get a whole lot of experience as to what it takes to develop this conference and to invite students from other universities and such. We also do community outreach. For example, recently we went to the San Marcos STEAM Fair and we held hands-on activities for the children and their families. We've also partnered with the San Marcos, Centro Cultural Hispano. And then we also do informal activities. For example, we've started doing faculty student pizza lunches where students can just kind of discuss whatever comes to their mind, whatever is helpful to them. And those have been really, really helpful. And other than that, we also do social events to try to kind of maintain that community.
Thank you. We'll move to Dr. Valles.
I thought it was going to be Dr. Davio. Okay,
Oh,
so
I'm sorry. We're out of order. We'll keep going with you.
okay, so the skills, knowledge, experience they get, one, they get to learn how to do engineering in AI, and I think that's a very marketable skill for them now. Most of them have computer science major or mathematics, statisticians, and engineering background classes, and so having the AI component in the resume is becoming a kind of crucial thing for them to do. But I think part of the experience they gain is understanding how to do that in a research lab, sometimes with a team, understanding what it takes to work with an advisor, faculty mentor that is guiding the project, and then they're becoming the engineer of the project, right? So they learn how to own the project. I think part of that is that it gives them a sense of responsibility to the work, and they learn how to show up every day. So one of the things of the transformations that we see over the summers is the engagement they have and the purpose they have in trying to achieve their goals. So it becomes a real work industry-like what computer scientists, what engineers go through with less at stake, right? But it's still the resiliency of them of finishing a project that is highly meaningful to them, and they understand that in accomplishing these goals is really beneficial for them in the future, whatever plans they want to do in the next summer or moving towards a certain career. And I think the experience overall, we try to cultivate that for them to feel like they can be that productive. And given that sense of that productivity, then the fruit of their work kind of shows up after the summer when we start publishing papers. And so we're very proud of doing all those things. So thank you.
Thank you. And back to Dr. Davio. Sorry about that.
I'd like to thank you again and THRC for organizing this. It's so wonderful to actually hear all the details, all the wonderful stuff that's going on at our university. So at IGI, Institute for Government Innovation, as I mentioned last question, we don't do a lot of formal training. We do more informal, customized training for the projects. Some constants that we try and do is we want the students to work for the entire project. So every project that we do is different, has a different time frame, that kind of thing. So when we're hiring students, we ask them to make a commitment for the entire length of the project so that they have that opportunity to go from absolute novice, not much familiarity with the topic, and to the expert in the room. That's what we tell them. It's like, you now know more about this than the executives and the people that are on our client team, because we've had the luxury of being able to focus all exclusively on this project. And so we try and really have that experience then has them go from, like I said, novice to expert. And part of that expertise also is in making presentations. So they get coaching on how to make good presentations, both in how to present, but also in how to formulate good slides that convey information effectively and simply and in a compelling fashion. We have a group that is going to present to Travis County Commissioners Court. These are undergraduate students that are getting to go and present, and that's an experience that many executives that haven't really had that opportunity. So it's a wonderful opportunity that we all cherish for them. And our clients love that we're working with students, and they like that feeling of helping them learn. So we do informal leadership things. Because we have students from all over campus, we maybe once a week or so we'll go on a walk. And so different students take the opportunity to lead that walk. So we get to go all over campus. They get to show off and tell their coworkers about their department, what they're doing, the buildings that they hang out in all the time. So it's a very informal, but it helps build a sense of camaraderie and community that feels like it's very important and sometimes missing from today's workforce. So we're trying to inoculate that through our students with, hopefully taking that out into the workforce. And they also just learn the importance of being very systematic in their work. If we do data collection, for example, for a project, they understand the importance of really doing that right the first time, not just sort of slapping at it. So we try and help them understand that. And, they learn whatever the project is. So it's a great opportunity for them.
Thank you. Dr. Whitten?
Okay, so I want to preface this first with the understanding that the students in the Bridge program, they receive professional development training almost weekly, throughout throughout the year, touching on topics such as, scientific writing, how to give a research presentation, how to write an abstract for a paper or a conference presentation, those sort of things throughout the year. They're getting that. But there, at least in my mind, there's really three key features of our training that I think it allowed us to be successful over the years. And the first one is the first semester that the students join the bridge program, they're required to take a semester-long course that we developed just for this purpose called Fundamentals of Research. And what that course does is it describes in detail, how to navigate the MS degree. A lot of students, if they don't have parents who went to graduate school, they don't really understand the differences between the undergraduate degree and the graduate degree, namely what's all involved with having a thesis and completing that thesis. And so there's a lot of training in that class as to how to navigate the MS degree, what they should be doing at different points of time throughout that 2-year degree program. Also in that course, we do a lot of NIH mandated training. So all students supported by the NIH have to receive some training in safety, ethics, rigor and reproducibility, those sort of subject areas. So we do that in that class. And also we start them on the path of having what's called an individual development plan where the student, thinks deeply about, what they want out of their career, where they want to be 1 year from now, where they want to be 2 years from now, where they want to be 5 years by now, and kind of map out that. And that's something that we go through with them throughout their 2 years here. Are you at this stage where you said you would be, and so forth. So we have that semester-long course that allows them to hit the ground running. Then at the end of their second long semester in the program, so basically at the halfway marks after 1 year in the two-year program, we have what's called a first year review, and all this is a review just to make sure they're making timely progress. But as part of this review, the student needs to submit a mostly complete draft of their introduction chapter to their thesis. And so this is helping them to prepare their thesis. At the 1 year point, they should have a very, very good idea of what their thesis project is, the context surrounding their project, and how they're going to go about testing their hypothesis or answering their scientific question. And developing the controls and stuff like that. So that's helping them to write it and helping them to understand their project at the 1 year point. Then they also have to give a 20-minute research presentation to the faculty, and that's helping them to practice talking about their work and explain it to others and people who aren't necessarily exactly in their same field. And one of the reasons we do that is, since these are students, we're trying to help transition from the MS to the PhD. And this is at the end of their first year. During their second year, they're applying to PhD programs and going on interviews to these PhD programs where they're going to be expected to talk about their research and the importance of it, the context of it, and exactly what they're doing, but in a succinct way. And so we have that at the midway point to make sure they're making timely progress. And then after that, there's a lot of development done to help prepare them for applying to PhD programs and going on their interview, helping them put together the components of a competitive application, getting strong letters, writing a strong personnel statement, and those sort of things. And so those are really the three key things that I think, over the last over a decade has helped us be successful in transitioning these students.
Thank you. We're going to go to our last question and back to Dr. Betancourt. And so here I would like to know, what are the benefits of your program for faculty who participate in your program or, work with student participants, extending through to your department and or industry or community partners?
Sure. So starting with faculty, I mean, one of the main things is the opportunity to work with one of these fantastic students, right? That in itself is a great, great additions to their labs. They're bringing in students who are super motivated, very excited about joining research, and some of them are really, really good. Another thing that we started with this is actually mentorship training. And this is something that actually started with a prior short program that some of you were involved in, where the faculty mentors received this training from the mentorship network. And I think Karen and Sean are here. They are actually trained to be trainers, and they happen to be associated with the PREM grant. And so this is something that we have made sure that our faculty mentors go through this training so they can learn new, ways of, communicating with their students and showing, being very clear about the expectations so that they can be better relationships that are productive and fair for everybody. Also, the faculty mentors who have participated in the program have been able to leverage PREM to obtain additional federal funding, be it through the research results that they have been able to obtain, through the collaborations, or through the equipment that has been brought. And so through that, our faculty have obtained a total of 17 grants, totaling more than $5 million over the last 4 years. And then many of the faculty members of PREM have obtained promotions and leadership positions. So it's been great for faculty. With respect to industry, one of the things obviously is a well-prepared workforce, right? We are preparing students to join their companies. The students not only receive significant training in their field, but they also learn in general how to troubleshoot, how to analyze, organize, and present their data. And they learn about what is going on in the industry in those fields. Also, we've been able to take advantage of the National Science Foundation's intern program. The intern program is not specific to PREMS. It's actually available to any funded centers. And what that provides is funding to be able to have a student, a graduate student, placed in an internship position at a company. So the company basically gets a full-time worker for up to 6 months that is fully paid by the National Science Foundation, with the idea that the student get the experience of working in industry for that time. So we've had the opportunity to provide that to 2 students. This year we couldn't, unfortunately. And then the other thing is that we do partner with industrial members for a number of different things, like for participating in career panels. Also right now for the camps conference that we're planning for the next month, we actually have sponsorship from industry. And so, the companies get their names out there among these students. And then with community, as I mentioned, we do a lot of outreach. So we do STEM demonstrations that are hands-on, that I hopefully get children excited about science in general and material science in particular. As I mentioned already, the San Marcos STEAM Fair, that's something that we have been participating in every year. We also do a lot of activities at the Centro Cultural Hispano, as I mentioned already. So I think that covers most of it.
Thank you. Dr. Davio?
We do collaborate with faculty. We worked with Damian, helped us on a project last year on advanced air mobility. He got to share his expertise, and so the students got to work with him. Our real focus, though, is on helping the community, whether that's government agencies or nonprofits. One of the projects that we're very proud of that's still ongoing, that's directly benefits the community and the Texas economy, is a website before-during-after.com. It's meant to improve small business disaster resiliency, but it actually has an emergency information hub on there that should be of interest to everyone, because it consolidates information from all the people that you want to know about when there's a disaster, or hear from when there's a disaster. So our primary focus is on helping the community.
Thank you. Dr. Valles?
Yeah, so the benefits for our faculties that most of the mentors are tenure track, so I'm trying to help them to mentor a student, first of all, be able to enhance their research for their promotion, their publications and a way to engage in a very meaningful research that can help their portfolio. And I think that goes hand in hand with the department. And we directly affect the community, right? Because we're working with human subjects that have a certain health need, and having volunteers helping us develop these technologies with AI. I think the impact there and the interest of the families, the caregivers of children with autism or people with spinal cord injuries or ankle injuries, and we tackled multiple sclerosis before. So the impact has been directly well known in our projects, and especially I think the students enjoy that part of our group. So thanks.
Thank you. Dr. Whitten?
Okay, so for benefits to faculty, I'd say probably the biggest benefit is a supported student in their lab, so the student doesn't have to have an outside job or be an instructional assistant. And really for the bridge students that are supported, we tell them in no uncertain terms that the reason they're getting a stipend is to give them that time to be in the lab, that the expectation is 20 hours a week during the long semesters and 40 hours a week over the summer. And we do our best to hold them to it. So I think the faculty get a student who potentially can be very productive. I can't remember the exact statistics, but a majority of our students are co-authors on a paper coming out of the lab of their research mentor here. So greater productivity. Also, as the Bridge program is a collaboration between us and UT Health San Antonio, we do try to encourage collaborative intercampus projects, and so that gives our faculty access to the facilities in San Antonio. So that's potentially helpful. I think the program has had a big impact on the department too. These sort of things that we've implemented to help our students make it through their MS degree with rigor and in a timely fashion, because one of the rules of these bridge programs is it's a 2-year MS program. We're only allowed to support the students for a maximum of 2 years, and so even if the student hasn't finished the MS, once those 2 years are up, there's no more support, and so we have developed things to reduce the average time to degree. And these sort of things that we've implemented, particularly the fundamentals of research. Now, all MS students in the department have to take that class, and so that helps. And then, at least for those students that are working towards the biochemistry MS degree, even if they're not a bridge student, they had to participate in this first year review too. And so it's helped reduce the average time to degree in our department. I would argue that it's helped to increase the rigor in the theses that have been presented. And so overall, I think it's had a good impact at the department level. As for the broader community, the biggest impact I would say was probably UT Health San Antonio, and so for these bridge programs, particularly MS to PhD, almost all the money goes to MS students and MS students at the MS granting institution. There's very little funds that are going to the PhD granting partner, but the idea there is by establishing these relationships, it helps to build a pipeline of some of our best students going to the PhD programs in San Antonio, and we've had a number of our students go there, and so there's been an impact at that level too.
Thank you. I want to take a minute to thank all of our speakers for coming together today and sharing information about their program and their students. And hopefully we all took away some information that is new and possibly have ideas for collaborations with individuals outside of our home department. Our next ECHO session is in exactly 1 week. We will be talking about building bridges. We're going to extend this conversation and bridges towards industry partnerships from startups to multinational corporations. And so we'll have 4 guests with us again. We'll have Antonio Cordova, who is the Regional Director for Nucleate Texas. We'll have Nancy Lyon, who's the director of the Austin Community College's Bioscience Incubator. We'll have Dr. Ryan Pendlerick from Texas State, who is the director of our Concrete Industry Management Program and a professor of practice in engineering technology. And we'll have Dr. Bailey Reeves, who's the director for the National Center for Therapeutics Manufacturing located at Texas A&M College Station.